Welcome back to 9.2 Pre-Calculus. We're moving on to number 19. Number 19, I see an r squared. What kind of graph are we going to have if we have r squared? You guessed it. We've got a lemniscate. What do lemniscates look like? Hopefully you're saying kind of like an infinity symbol, right? This one is sine 2 theta. Normally, we would say anything with a sign in it is symmetrical about theta over 2. I mean, theta is equal to pi over 2. But we're going to see on this one it's not quite. So I'm going to hold off on symmetry. We'll talk about that when we're finished. So let's find our maximum r value. Remember, sine 2 theta oscillates between what two values? Between -1 and +1. So if sine 2 theta is -1, r would become, because this is r squared, it's going to become the square root of 9 times -1. Is that going to be possible, the square root of -9? No, so this does not exist. And if sine 2 theta is 1, then r is equal to the square root of 9 times 1, which is square root of 9, which is 3. So our maximum r value is 3. And then when is that true? We've got 3 squared is equal to 9 sine 2 theta. Well, 3 squared is 9. If I divide both sides by 9, we get 1 is equal to 1 sine, not 20, Miss Harris, but sine 2 theta. All right, when is sine equal to 1? That would be at pi over 2. But because it's 2 theta, we got to add 2 pi to it, go all the way around the circle one more time. Adding 2 pi to it, we get 5 pi over 2. And then when we divide by 2 to find our thetas, we get this occurs at theta is equal to pi over 4 and 5 pi over 4. All right, our zeros are going to be when 9 times sine 2 theta is equal to 0. Dividing by 9, we still get 0 is equal to sine 2 theta. Sine is equal to 0 when 2 theta is equal to 0 or pi. But keep in mind, we have to go around because it's 2 theta. We're going to make one more trip around the unit circle. So adding 2 pi to 0, we get 2 pi. Adding 2 pi to pi, we get 3 pi. And our last step is to divide each of these guys by 0. So we are at 0 when theta is equal to 0 divided by 2. Pi divided by 2. 2 pi divided by 2 would be pi. And then 3 pi over 2. So remember, this is that infinity type shape of our graph. We know we have zeros at 0, pi over 2, pi, 3 pi over 2. So remember when I'm doing these, and this is kind of like a rose-ish kind of shape. It's just we have some petals that exist and some petals that don't. So I'm going to put in my guidelines like I usually do for the roses. And then these are my petal ends. At pi over 4 and 5 pi over 4, my r is 3. So at pi over 4, we're at 3. And at 5 pi over 4, we are also at 3. And so my infinity symbol ish looking thing is going between those two. Now, what kind of symmetry does this one have? Like I said, we would normally say it has symmetry across theta equals pi over 2. The problem is because of these does not exist, we don't have the petals that would be here in the second quadrant and the fourth quadrant. So we are not symmetrical across theta over 2. Theta is equal to pi over 2. I don't know why I cannot say that. Theta is equal to pi over 2. We do not have that symmetry, but we do have symmetry for this one. We are going to be symmetric across the pole. In other words, this piece here is a mirror image of this piece here on the other side. All right, that's it for number 19. One more video today, and then you'll move on to IXL.